students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to revise the complete amines chapter and we are going to solve a lot of practice questions also. So as we know, we have already completed all the three organic chapters and also we have discussed amines in detail. So today we'll make a brief revision of this chapter. Okay, and one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So this if you join the WhatsApp channel, you will get access to our PDF notes, you can get access to mock test solutions, everything. So it is a request, it will be beneficial for you, so please join the WhatsApp channel. Okay, so now without any further delay, let's get started with the revision of amines. As I say in every class, please sit with the notebook and pen and note down all important reactions and important definitions and points. Okay, fine. So now let's get started. Weightage, you know, we have already discussed, so you can expect 2 to 3 questions from this chapter. Okay, 2 to 3 questions every year. It is asked on alternate, you can say 2 3 2 3 3 2 3 2. So alternative year 3 or 2 questions have been asked. So this is a must do topic, this is a small topic and also very easy chapter. Okay, fine. Now coming to revision, what are we going to revise today? First, we'll be talking about preparation of amines, what are the reactions, next physical properties, next chemical properties, preparation of diazonium salts, physical properties and chemical reactions. So these three are for diazonium salts. Okay, diazonium salts, and this one is for amines. Okay, clear? Now coming to preparation of amines. So what are the different types of reactions, or which type of reactions will give you preparation of amines? So first one is reduction of nitro compounds. Second, a monolysis of sorry, this is your topic 1. Okay, yeah. So first we have reduction of nitro compounds, then we have a monolysis of alkyl halides, then you have reduction of nitriles, reduction of amides, next you have Gabriel phthalimide synthesis, and then you have Hoffman bromamide degradation. Okay, so these all are your 1.1, 1.2, 1.3, 1.4, 1.5 and 1.6, right? So 6 methods of preparation. So here I'll note down that in the preparation methods, how many methods are there? 6 methods. First is reduction of nitro compounds. Second, a monolysis of alkyl halides. Next you have reduction of nitriles. Okay, next you have reduction of amides. So you have 3 reduction methods, right? One is reduction of nitro compounds, reduction of amides, reduction of nitriles. Then you have a monolysis of alkynes, a monolysis of alkyl halides. Then 2 name reactions, Gabriel phthalimide synthesis and Hoffman bromamide degradation. Okay, fine. Next, coming to preparation of amines. So the first method, as I told you, is from your reduction of nitro compounds. So if you see, this is the first method, right? Reduction of nitro compounds. Okay, so what is the reagent used here? For RNO2, if you treat it with SnHCl or FeHCl, that is one way, or you can treat it with H2 palladium and ethanol. Okay, so this will give you NO2 group will get converted to NH2. Now if you are using SnHCl or FeHCl, we call it Stephan reduction. Okay, this particular reagent, if it is used SnHCl or FeHCl, then we call it, this name reaction is Stephan reduction. Okay, first one. The second method was from a monolysis of haloalkanes, right? The second method here I'll write a monolysis of haloalkanes. So now if you treat ammonia with any Rx, right? So X is delta minus, R is delta plus. Here nitrogen has a lone pair of electrons, so it acts as a nucleophile. So this one will attack here, on this X will go and then we'll get a salt, and after that if you treat it with NaOH, we'll get RNH2. Okay, now what happens, this reaction can proceed further also. A primary amines can react with Rx to give you secondary amines. Secondary amines can react with Rx to give you tertiary amines. Tertiary amines can react with Rx to give you quaternary amines. Clear? Second method. So first method was reduction of nitro compounds, second ammonolysis of RX, third one is your reduction of, third one was reduction of nitriles, that is RCN, right? So this is your third method, reduction of nitriles, right? So what are the reagents to reduce this one? So we have hydrogen nickel, one we can use, or you can use lithium aluminium hydride, or you can use sodium with ethanol, sodium amalgam with ethanol, H2 nickel or lithium aluminium hydride, or Na in presence of C2H5OH. So this one will give you RNH2. One thing you have to remember, the number of carbon remains same here. RNH2 remains. Suppose here you have like CH3, C triple bond N. Then if you use this reagent, you will get CH3, CH2, NH2. Right? The number of carbons remains same here. Okay. Now coming to the fourth one, that is reduction of amides. Reduction of amides. RCONH2 with LiLH4, it will give you again RCH2NH2. Okay, RCH2NH2. Clear? Next, coming to your name reaction, that is Hoffman bromamide degradation. Hoffman bromamide degradation. Okay, so now here what happens if you use this CO group? Okay, this CO group is removed and we get RNH2. So what is the speciality? We get one carbon less. Okay, the compound or the product formed here is one carbon less. Okay, so this is your five methods of preparation of amines that we have discussed. So there are total 6 methods. These are 5 methods of preparation. The first one is reduction of nitro compounds. Here you can use SnHCl or FeHCl, or you can use reduction of or you can use H2 palladium in presence of ethanol. Now this will give you RNH2. Okay. Now this, if you use SnHCl or FeHCl, we call it Stephan reduction. Next, second point, the second method is ammonolysis of haloalkanes. So here you just need to use any RX with ammonia. So first there will be a salt formation, then you use NaOH, you will get primary amines, then you use it with RX, you will get secondary amines, again RX, tertiary amines, again RX, you will get quaternary amines. Clear? Now coming to the third one, that is reduction of amides or reduction of nitrile. So here also you can use 3 reagents. One is your H2 palladium or lithium aluminium hydride or sodium amalgam in ethanol. Clear? Now coming to the fourth one, that is your reduction of amides. So with LiLH4 you can easily do it. Next, the same thing, reduction of amides only, but you can use bromine KOH or NaOH. This one will reduce one carbon less. Okay, you will get a amine less, like whatever is the parent, whatever is the number of carbons in the amide, less than that one carbon will be the number of carbons in the amine. Okay, for that you need Hoffman bromamide degradation. Now next one is, and one more thing, here you should remember that this amide must be a primary amide. Okay, means it has to be RCONH2. If you replace this H with any other alkyl groups, then this reaction will not happen. Okay, next coming to the sixth method, that is Gabriel phthalimide synthesis. Right, this is a name reaction. Okay, Gabriel phthalimide reaction. So here what happens, this is a compound is called as phthalimide. Okay, now if you treat it with KOH, so what happens, this H plus and OH minus is removed and N minus and K plus is formed. Then if you treat it with RX, then NR is formed, right? After that, if you treat it with NaOH, so this gets reduced to NH2 to give you a primary amine. Okay, fine. So now let us discuss here all the methods with the reagents. Okay, for reduction of nitro compounds, what are the reagents we have discussed? We have 3 reagents here, right? One is your H2 nickel or palladium, then you have SnHCl or you have FeHCl. right? Ammonolysis, just simply you have to treat it with NH3, then you have to treat it with NaOH. Nitriles, you have to use, again here also we have 3 H2 palladium, or you can use LiAlH4, or you can use sodium amalgam with ethanol. Next, for amides, you have to use LiAlH4. For Gabriel phthalimide, the whole reaction is there. Hoffman bromamide, you have to use Br2 in presence of NaOH or KOH. Clear? Here you should remember 1 carbon less product will be formed. Okay, fine. Next, coming to physical properties of amines, talking about their solubility and boiling point. So solubility, lower aliphatic amines are more soluble. If the R group increases, the solubility will decrease. Okay, and coming to boiling point, so boiling point depends on the hydrogen bonding. Okay, so primary amines will be more effective in hydrogen bonding because they have 2H. Secondary amines have only 1 hydrogen. Tertiary amines do not have any hydrogen. So hydrogen bonding is stronger in primary, then secondary, and then tertiary. So based on that, the boiling point order is also this one. Okay, now let us go to the third topic of the revision, that is chemical reactions. Okay, so let us see. So preparation methods, remember 6 methods are there. So whenever you revise, you need to recall those 6 methods of preparation. Now coming to chemical reactions. So under chemical reactions, first thing we need to understand, very important, is the basic nature. Okay, so yeah, basic nature is very important in amines. There are questions have been asked repeatedly from the basic nature. Next, you have alkylation, next acylation, then you have carbyl amine reaction. This is also very important reaction. Then reaction with nitric acid. Next, we have reaction with aryl sulfonyl chloride, and then electrophilic substitution reaction. Okay, this is also very important. These all reactions are very important reactions. Okay, so how many reactions we have? 7 reactions. First, you can consider it not as a reaction but a chemical property, right? So first thing, we'll talk about basic nature. Next, we have alkylation, then we have acylation, then you have carbyl amine reaction, then you have reaction with nitric acid, reaction with benzene sulfonyl chloride, and reaction, the last one, electrophilic substitution. Okay, so now let us understand this. Okay, under electrophilic substitution, you have nitration, sulfonation, and halogenation. Okay, so let us start now. First thing, that is your basicity. Understanding basicity is very important. So in gaseous phase, the basicity order you should remember 3 degree, 2 degree, 1 degree. Okay, 3 degree, 2 degree, and 1 degree. In aqueous phase, there are 2 effects or 2 factors that play a role in deciding the basicity. What are these 2 factors? First is your inductive effect, and second one is solvation effect. Okay, according to inductive effect, the order is 3 degree, 2 degree, and 1 degree, which is there in the gaseous reaction. And according to the solvation effect, the order is 1 degree, 2 degree, and 3 degree. Now when this both effects mix, and when we find the effect of both of them, we get the order like this. We get 2 degree, 1 degree, 2 degree, 3 degree, 1 degree if this R group is your ethyl group. Okay, so remember, if it is ethyl group, okay, then we have the order 2 degree, 3 degree, and 1 degree. And if it is methyl group, if R is equal to methyl group, then we have 2 degree, 1 degree, and 3 degree. Clear? Next, if you combine aryl amines and ammonia, aryl amines are less basic. Why? Because aryl amines, if you have NH2 group, right, the lone pair of nitrogen is involved in resonance. Because it is involved in resonance, the basicity decreases. So this point is very important. In aqueous phase, 2, 3, 1 for ethyl group, 2, 1, 3 for methyl group. Okay, fine. Next, coming to one question here, the decreasing order of basicity, basic characters of the 3 amines and the ammonia is. So you have been given with CH3NH2, Okay, let me first write down all the 4 compounds: NH3, CH3NH2, C2H5NH2 and C6H5NH2. Okay. Now if you have seen, ammonia will be less basic than primary or secondary amines, right? So here you will have more donation, more groups can donate the electrons. So that is why C2H5NH2 will come first, right? Then it will be CH3NH2, right? Then ammonia and then aryl amine. So aryl amine has to be in the last, right? So that is why these 2 options we can delete. Before aryl amines it has to be amines, so it has to be ammonia, so we can delete this one. So option B will be the correct answer. Okay, fine. Now let us go to the chemical reactions. So we have discussed 1 chemical properties, that is the basicity. Second, chemical reactions. There are 6 chemical reactions. The first one is your alkylation. Okay, so let us see that. So the first reaction here is alkylation. Now what is exactly the meaning of alkylation? So if you see, in an amine there are 2 hydrogens, right? If you want to replace any one of this hydrogen or both the hydrogens with a alkyl group, then it is called as alkylation. So to do that, what you have to do, you have to react it with a R group. So if you see here, this is delta plus and this is delta minus. This one will attack on this one will go. So we will get RNRRNH. That is alkylation. Now for acylation, what will happen? This RCO group, okay, will replace one of the H in the amines group. Okay, so we will get acylation. So this is your second one, right? So this group is called as acyl group, attached to the nitrogen. Alkylation, acylation. The third one, okay, acylation can also be done if you react it with any anhydride. So you can react with acid chlorides or you can react with anhydrides. So here what will happen? This RCO group will be replaced. Again we will get a here you can see the acyl group is attached. One H is replaced and the acyl group is there. And you can also do this one if this group, R group, if it is a benzene ring. In case if it is a benzene ring, then we call this, so you can see one of the hydrogen of NH3 group or NH2 group has been replaced with a benzene group here. So this is called as benzoylation. Okay, very similar to acylation, but a different name is given and it is called as benzoylation. Okay, next you have third reaction here, that is your carbyl amine reaction. Carbyl amine reaction. So here what happens? Primary amines react with CHCA3 in presence of KOH to give you R and C, and this is what? Isocyanide group. Okay, and this isocyanide creates a foul smell. Okay, this is the thing that you must remember about this carbyl amine test, that is foul smell is produced, and this test or this reaction is only given by primary amines. So it can be used as a test to distinguish between the primary, secondary and tertiary amines. Like primary amines you can find out easily from this one. Carbyl amine test, what will happen? If you treat RNH2 with CHCl3KOH, it will give you RNC, that is a isocyanide product which has a very foul smell and can be easily tested. Okay, and next one is your reaction. So next one is fourth one, reaction with nitrous acid. Okay, so here you should remember, if this R group or if it is an aliphatic amine with HNO2, it will give you alcohol group. But if it is an aromatic amine, means it is aniline, then with HNO2 it will give you benzene diazonium chloride. Benzene diazonium chloride. Clear? So with RNH2, in nitrous acid aliphatic, you will get alcohol. With HNO2, if it is an aniline, you will get benzene diazonium chloride. Okay. Next you have CHCl3KOH heat. If you this, you will get isocyanate, that is a foul smell, carbyl amine reaction. So by now we have discussed 4 reactions. Total, if you remember, we had 7 chemical properties. First one was basicity, second one alkylation, third one acylation, fourth one reaction with carbyl amine test, fifth one nitric acid or nitrous acid, then Sixth and seventh is still remaining. Benzene sulfonyl chloride. Sixth one here is reaction with benzene sulfonyl chloride. Okay, so what is this? This reagent, okay, this compound is also called as Hinsberg reagent. Okay, Hinsberg reagent. Now what is the role of this one, or why it is used? To distinguish or to test primary, secondary and tertiary amines. Okay, now I'll tell you how. Now see, this is a primary amine, so you can see only one H is replaced with R group, so it is a primary amine. Now this one will react and we will get HCl will be removed and you will get this product, right? Now this one is having a H attached to it, right? So that means this H is acidic in nature, so this can react with an alkali and it will be soluble in an alkali. Okay, so primary amines will create a salt, okay, and that one will be soluble in an alkali. Okay, not salt, sorry, it will create a compound which will be soluble in the alkali. Next, if you do same thing, if you do, what will happen? One H and Cl will go and this NRR part will be attached here, so that is there, and here you see there is no acidic H is not present, so this one will be insoluble in alkali, right? Now if you see tertiary amines, so this is primary, let me write down here, this is secondary and this is tertiary. So this tertiary amines will not react with benzene sulfonyl chloride at all because they do not have any H here, remember? So this is how you can differentiate between primary, secondary and tertiary amines, clear? Now let us move towards the seventh reaction, that is electrophilic substitution reaction. Under that I told you we have three reactions: halogenation, sulfonation and nitration, right? So now if you treat it with bromine water, this is an electron donating group, okay, so it will be ortho and para directing, so all the three positions are replaced with bromine group, okay. Now if you treat it with nitric acid, we get ortho, para and meta products, all the three. Here one interesting thing you should know, that if it is an electron donating group, we should get ortho and para product as the major product, but here meta product is also almost, you can see, 47% and para product is 51%. Now this is a question asked many times, why does that happen? So this is an basic in nature, right? This ammonia has basic nature, so that is why it abstracts this H plus and now it becomes NH3 plus, okay. Now NH3 plus is electron withdrawing in nature and that is why it is meta directing. So even that's why we get even a major percentage of meta compounds, okay. Next, if you see for sulfonation, if you just use H2SO4, so this is a base, this is an acid, so what happens, we get a salt first and then there is some what we say arrangement and then we get SO3H here, and after that there is a proton transfer and we get this compound finally for sulfonation. Now suppose you want to get only one bromo substituted product. If you do with aniline, because it is a highly activating group, we are getting all ortho para positions are substituted, but there is a way how you can do only, you can get ortho para product, like you can get only para product. There is a way to do that. How can we do? So you need to reduce the reactivity of this aniline group. So for that we treat it with acetic anhydride with pyridine, okay. So if you treat it with acetic anhydride in presence of pyridine, we get this compound, okay. Now after getting this one, if you treat it with bromine in presence of acetic acid, then you will get para product, okay. Then if you want the NH2 back, you have to just do OH minus or H plus, you treat it with this one, then you will get NH2, okay. Similarly, if you have this NHCOCH and you treat it with the nitration, concentrated HNO3 and H2SO4, you will get only para product and then you can convert this one to NH2 group like this, okay. So clear? So if you treat directly with bromine water, you will get both, all ortho para positions will be substituted. If you get only nitric acid, if you take for nitration, you will get all the three ortho, para and meta substituted products, para will be 51% and meta will be almost 41%. To reduce the reactivity of NH2 group, we do acylation, okay, and this will reduce the reactivity and we can get only para products, okay. So that is what is here. Now let us revise the let us revise the reactions and the reagents once again. Okay, so for basicity, what is the nature? So if you in gaseous phase, what is the order? Sorry, one second. Yeah, in gaseous phase it is 3 degree, 2 degree and 1 degree. In aqueous phase the order is 2 degree, 2, 3, 1 if it is ethyl group, and it is 2, 1, 3 if it is methyl group. Remember? Then for acylation, what all things we can treat? We can treat CH3COCl, right? Or you can treat anhydride, that is CH3CO whole 2O, or you can treat with benzyl C6H5COCl. Okay. Now if you want to treat it with carbyl amine reaction, okay. So for carbyl amine reaction, you have like you can treat it with CHCl3KOH, okay. Then you will get isocyanate compounds which gives you a foul smell. Then treating with nitric acid, so if you have aliphatic amine RNH2, right, it will get converted to ROH. But if you have benzene like aniline NH2, then this will get converted to benzene disonium chloride, right. Next, if you react with Hinsberg reagent, so what are the things you remember? Primary will be soluble, secondary insoluble, and tertiary no reaction. Here nitration, you have to reduce the reactivity to get only para product. If you do directly, you will get ortho, para, all the 3 substituent products will be forming. Clear? So yes, that was all about the chemical reactions of amines. Now we will go to benzene disonium chloride preparation. We have already seen now. Just take aniline, okay, take aniline and then react with HNO2 or nitric acid. This will give you benzene disonium chloride, okay, benzene disonium chloride, okay. So next, coming to its physical properties, it is a crystalline colorless solid and it is soluble in water. Now going to the most important thing, that is the chemical reactions. So there are 2 types of reactions which involve here. One is reactions involving the displacement of N2 group. Means, see, one second. Those reactions where this Cl minus is anyway not a part of this compound, it is a salt, right? So this N2 will go and in place of that some other group will come. That is called reactions involving the replacement or the reactions involving the replacement or the displacement of N2 group. And there is another coupling reactions. Now under this reactions involving the displacement of N2 group, we have replacement by Cl minus or Cn minus, replacement by I minus, replacement by F minus, replacement by H, replacement by OH, and then replacement by NO2. So there are total 6 replacements we can do. Like we have Cl minus or Cn minus, F minus, I minus, then H, OH, NO2. Okay, so we will see if I want to replace N2 with Cl, then which reagent we need. Okay, so that all things we'll see. So the first one is replacement by Cl minus. So for that you can use Cu2Cl2HCl. If you want to replace with Br minus, then Cu2Br2HBr. Okay, so you see what will happen. This N2 group will be replaced with this Cl group. N2 group replaced with Br group. Now again, if you want to react with Cn, then CuCN, KCN, that is you will be getting N2 group replaced with Cn group. Okay. Now these type of reactions where you use copper salt, then copper salt, this is called as Sandmeyer reaction. Okay. Now if you use only copper and HCl, still you will get the same product, chlorobenzene. Copper HBr, you will get bromobenzene. But here you are using metallic copper but not copper salt. So these type of reactions are called as Gattermann reaction. Okay. So these 2 things are coming under replacement by Cl minus or Br minus or Cn minus. Okay. Now second one is replacement with I. Second one is replacement by I minus. So for that you need to treat it with Ki, okay, and this N2 group will be replaced with I group, okay, so we'll get ARI. The third one is replacement by one second. Third one is replacement by F minus. Okay, so for F minus you can treat it with HbF4 first. Okay, now here if you see, this is H plus, this is BF4 minus. So what will happen? N2 plus will take this BF4 minus. One salt of this type is formed, then you just need to heat it. So if you just heat it, you will get ARF or fluorobenzene. Okay, so that is the third one, replacement by F minus. Next, fourth one was replacement by H. Okay, so for that you can have two reagents. Okay, fourth one, replacement by H. So for that you can use H3PO2 and water. So that will replace this one N2 plus with H, that is one method. Or you can use ethyl alcohol, ETOH, that will also replace N2 with H. So remember what are the reagents? H3PO2 and water or ethyl alcohol. Okay, next you have fifth one, that is replacement by OH. So by OH, for that simply you need to use water. If you use water, it will get converted to phenol group. Okay, this N2 part will be replaced by OH group. Okay, next sixth one was replacement by NO2 group. I will write here, by NO2, sixth one. So first it is treated with HbF4 like how we have done for fluorobenzene. You will get N2 plus BF4 minus. After that you heat it with Na, NO2 and copper, and this one will convert this whole group to NO2 group. That is your replacement with NO2 group. Okay, so now let us see here again, let us revise. For replacement of Cl minus you have two things, CuCl HCl, or you can use CuCl2 HCl. Yeah, Cu2Cl2 HCl, or you can use CuHCl for chlorination. For bromination, Cu2Br2 HBr, right, or CuHBr, right. This is called as Sandmeyer reaction and this is your Gattermann reaction. Done. For Cn minus you can use CuCN and KCN. Okay. Now for replacement with I you need just simply Ki. For replacement with F minus, we need first HbF4, then a salt will form, then you need to heat it, right. For replacement of H, you have two things, one is your ethyl alcohol and next one is H3PO2 in presence of water. Next, replacement by OH, you have water, and replacement by NO2. For that again you need to first treat it with HbF4 and then treat it with Cu and NaNO2. Clear? Done? Okay. Now coming to coupling reactions. So coupling reactions, if you see, first one you have benzene diazonium chloride and you treat it with phenol. So what will happen? This HCl will be removed and you will get a coupling reaction like this, and this is called as para-hydroxyazobenzene. Okay, para, this is the para position, para-hydroxy, this is your azobenzene group. Similarly you can treat it, this is phenol. Okay, you can also do this coupling reaction with aniline. Okay, so here again what will happen? This HCl will remove, so you will get this one, so you will get para-aminoazobenzene. Okay, now this para-hydroxyazobenzene is orange in color and para-aminoazobenzene is a yellow dye. Okay, this is an orange dye and this is an yellow dye. Clear? Okay, so that's all about all the reactions. Now we will practice a lot of questions. Okay, fine. So this was a homework question I think I have given you in my previous class. An aromatic compound A, C7H9N, on reacting with NaNO2 and HCl forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A is. Okay, so if you see here, an aromatic compound A, C7H9N, on reacting with NaNO2 and HCl at 0 degrees Celsius forms benzyl alcohol. So if you treat with nitrous acid and it is giving you a benzyl alcohol, that means it must be a primary amine. So what must be A? A must be like, the structure of A should be like this, CH2 NH2, right? Now you have to tell the isomers of this one. So we can have like this, we can have NH2 here, and then we can have CH3 in the 3 positions, that is ortho, para and meta, right? So I can have NH2 here, and then meta position CH3 here, and then I can have NH2 here, okay, and in the para position CH3. Then one thing you can do, another one, you can have secondary amine, right, NH and CH3, right? So this will give you 1, 2, 3, 4 and 5 isomers. The correct answer is option number A. Okay. Next, amines are derivatives of. So if you know, if you replace the hydrogens of ammonia, we get amines. So they are the derivatives of ammonia, right? Very easy question. Next, what is the expected geometry of CH3 NHCH3? So ammonia geometry is pyramidal, so it will be trigonal pyramidal, right? So the structure will be like this, N, CH3 and then H, and then you have CH3, and then here you have one lone pair, okay, pyramidal structure. Which of the following reagents cannot be used to convert ethane nitrile to ethyl amine? So you have ethane nitrile, right, ethane nitrile, CH3 CN, and you want to get it to ethyl amine, right? Okay. So we have seen for nitriles we can use H2 nickel, LiLH4 and sodium amalgam, but SnHCl is for the reduction of NO2 compounds, right? This cannot reduce a nitrile compound. So the correct answer for this question will be option number D, right? Option number D. Okay, next. How many more carbon atoms are present in the amine formed from the reduction of a nitrile than in the nitrile itself? Okay, how many more carbon atoms are present in the amine formed from the reduction of a nitrile? So if you are reducing a nitrile, okay, and you are getting an amine from that, so it is asking that, right, how many more carbons are present in the amines formed from the reduction of a nitrile than the nitrile itself. So but if you remember that the number of carbons present in the nitrile is equal to the number of carbons present in the amines, so it has to be 0. The number of carbons is not more, it is equal. Okay. Okay, now if you see this one, we will get product, you can easily guess, the CN group will be reduced, so we will get CH2 CH2 NH2, right? So this is 1 2, so we will have 2-phenyl ethanamine, right? So correct answer is option number C. Next, ethyl dimethyl amine is obtained from the reduction of dash with LiLH4. So we need to obtain what? Ethyl dimethyl amine. That means you have one side methyl, another side methyl, and then you have ethyl, right? Ethyl dimethyl amine. Now this one can be produced by the reduction of a with LiLH4. So if you see, we have N dimethyl acetamide. If I have this compound, that means what? You have N dimethyl CH3 CH3 acetamide CO NH2, right? Okay, sorry, one second. This is not the structure. N dimethyl acetamide, right? So we have like this CH3 CO, then you have N, you have CH3 CH3, right? So this is N dimethyl acetamide. So if you reduce this, this one will get converted to CH2. So we will get this compound, right? So correct answer for this question is option number D. Next, the best reagent for converting 2-phenyl propanide to 1-phenyl ethanamine. We have 2-phenyl propanamide. So let us first draw propanamide. This is your propanamide, and on the second position you have phenyl group, right? 2-phenyl propanamide to phenyl ethanamine. So you have phenyl ethanamine, right? So now if you see what will happen, you just need to remove this group. To remove this group, we will get this compound. We need Hoffman-bromamide degradation, that is bromine with NaOH. So option number D. Next, which of the following amines can be prepared from Gabriel phthalimide synthesis? So if you remember, this is used only for the synthesis of primary amine, right? Aniline not there, orthotoluidine not there, and methylbenzenamine not this one, benzyl amine, that is CH2NH2. CH2NH2, primary amine. So correct answer is option number A. Okay, let us see the next question now. Which of the following steps is not present in Gabriel phthalimide synthesis? So if you see that treating phthalimide with alcoholic KOH, that is there. Heating potassium phthalimide with alkyl halide, this is also there. Alkaline hydrolysis of N-alkyl phthalimide, this is also there. Heating phthalimide with phthalic acid with NaOH. So there is no phthalic acid formed here. So correct answer for this question will be option number D, right? Option number D, this step is not there. Next, starting from propanoic acid, the following reactions were carried out. What is compound Z? So if you see propanoic acid, that is CH3CO, one more carbon will be there, right? So you have CH3, so we have CH3, CH2, COOH, right? Now if you treat it with SOCl2, what will happen? This Cl will be, this OH group will be replaced with Cl, right? Now if you treat it with NH2, then what will happen? This group will be treated, will form amide, right? Next, if you do bromine, that is Hoffman-bromamide degradation, we will get CH3, CH2, NH2, right? So we will get ethanamine. So that is your this one. Correct answer is option number B here. Next, in the given equation, what is the final product C? Okay, so again same type of question, OH is there, so it will be replaced with Cl. So I will get CH3COCl, right? Next you have NH3, so this one will be getting converted to NH2. Then NaBrO, this is again converted to, this group will be removed, right? So I will get CH3NH2, right? So that is your aminomethane. So correct answer is option number C here. Next, what will be the product of the following reaction? So first of all, you are treating it with LiLH4, right? Then hydrolysis. So this will convert this one to amine group. So I will get CH3, CH2, CH2, and H2. So that is propanamine. Correct answer is option number A here. Next, what will be the product of the following reaction? So here you have seen that the same thing, this one will get converted to CH2 group. So I will get CH2, then I have N, I have H, and I have CH3, right? So this is a secondary amine. So I will get N-methyl propanamine, right? N-methyl propanamine. So correct answer is option number B. Okay. Next, what will be the product of the following reaction? So same, this one will get converted to CH2 group. So I will get N and dimethyl propanamine, option number C. Okay. Next, see the next question. Which type of amine is produced by the reaction of ketones with primary amines? So if you have ketones like this, right, and you are treating it with primary amines, so what will happen? First there will be removal of this one, water. So I will get NR. Then there will be reduction. So I will get CH, then we will get N, H, and then R, right? So if you see here, for this N, two groups are replaced, right? So we will get N and di-substituted amine. So correct answer is option number C here. Okay. Now coming to the next question, which of the following compound is expected to be most basic, right? So if you see aniline, least basic, ethylamine, methylamine, ethylamine is more basic. So correct answer is option number D here, right? Next, which of the following statement is true about methylamine? Okay, methylamine is slightly acidic. No. Methylamine is less basic than ammonia. No. Methylamine is a stronger base than ammonia. Yes, that is correct. Methylamine forms salt with alkali. No, this is already a base, right? So it will form salt with acid. So correct answer is option number C here. Next, if methyl is alkyl group, then order of basicity, that is 2 degree, 1 degree, and 3 degree, right? So you have 2 degree, 2 degree, 1 degree, 3 degree, option number A. Next, identify the product Z in the following reaction. Okay, so first of all there will be what? This is acylation, that is your protection of amine group, right? We'll get this one. Next, Br2CCl4 will get only para position. Then if you treat it with water, this will get converted to NH2. So we will get para bromoaniline. Okay, correct answer is option number A. Next question, the reaction shown below gives you. So you have tertiary amine and then you have CH3COCl, right? So if there would have been any H here, right, then the HCl will be removed, the H of the amine will be replaced with the COCl group. Like for example, see, if you have RNH2 and then you are treating with ClCOCH3, in that case this one will be removed and we will get RNHCOCH3, right? But here you see there is no H, so this reaction will not happen. So correct answer is option number D, that is no reaction. Okay. So next one, certain amine X when heated with chloroform and alcoholic KOH produced no reaction. Identify X from the following. So if you are treating it with chloroform and alcoholic KOH, this reaction is only given by your primary amines, that is carbyl amine test, right? They will form isocyanates which have a foul smell. So now if you see primary amine, this one will give ethylamine, this one will give ethyl methylamine. So if you see this one is a secondary amine, so this one will not react. Correct answer is option number C here. Next, which gas is produced when ethanamine reacts with nitrous acid? So gas produced here is N2 gas. Next, diethylamine reacts with nitrous acid in the cold to form. So if you remember, primary amines reacts with nitrous acid to give you alcohols. Okay. Secondary amines, you should remember here, reacts to give you nitrosoamine. Okay. Correct answer is option number D. Next, which of the following amines on reaction with benzene sulfonyl chloride will give a sulfonamide that is insoluble? For insoluble, it is the condition is it should be a secondary amine, right? So if you see, this is primary, this is tertiary, so this will not react. This is again primary, this is secondary. So correct answer is option number B here. Next, which of the following reactions or test does not help in distinction between ethylamine and diethylamine? So this is primary and this is secondary. Carbylamine test, yes, primary amine will show positive test, so we can use this. Hinsberg test also we can use. Reaction with HNO2 also we can use, because this one will give you, just now I told you, alcohol, and secondary will give you nitrosoamine. But reaction with CH3, CH2Br, we cannot use this to distinguish between them, because none of them will react with this one. Okay. Oh, sorry, both of them will react. So correct answer is option number D. Okay. So here's a homework question now. What is the major product formed when aniline reacts with bromine water at room temperature? Very easy question. We have discussed this reaction today. I hope everyone would have answered this question in the comment section. Okay. So yes students, so now we are done with the revision of amines chapter, and I hope you have liked this video, you have made notes, and that you can use as a short note for your revision. Okay. So hope you have enjoyed this video. So thank you for watching. Please subscribe the channel, and see you soon in the next episode, where we are going to start a brand new chapter, that is biomolecules. Okay. And do not forget your target, that is 60 out of 60 in KCET Chemistry 2025. Okay. See you soon in the next class.